a uniform rope of length L lies on a table. If the coefficient of friction is mu, then the maximum length L1 of the part of this rope which can overhang from the edge of the table without sliding down is. This is an easy question. Just we need to know few concepts here. They gave mu, which means there is a friction. So the friction formula is mu n. So mu mg. This is very important concept here. If you multiply the coefficient of friction and mass and g value, you will get some value, final value, which is the maximum friction can be given to the rope. In case if you after multiplication, if you get 20 Newton, example, in case, which means the overall frictional force can be given to the rope is 20 Newton. So if you apply more than 20 Newton, even a little of force, then the rope will slide down and fall down. So this is the main concept. The friction is given here, just keep in mind. And I am drawing a table here, and there is a rope. The total length of the rope is L, and some portion is hanging here, and this length is L1, the hanging rope, and this length L minus L1 from this point to this point, because the total length is L. And we know this L1, this small portion, is pulling the complete rope downwards, and the rope which is resting on the table, lies on the table, is pulling the rope in the opposite direction because of the friction. The friction is pulling in the opposite direction. So finally the rope is not falling down, which means it is balancing. The frictional force is balancing the pulling force. Okay. So here at the middle, at the center of mass, the weight is acting downwards. So we can find the weight of this resting or the lying rope on the table. That is mass times g value. So first we have to find the mass of the resting rope. How do we find the mass? The total length of the rope has total mass per total length. The mass is distributed equally. So every section, every equal length has equal amount of meters, which means same masses. So you can mention here mass per unit length, total mass per total length, multiply by L minus L1, because we have two sections here. This section mass per unit length multiply by L minus L1. So that is the mass of the resting rope. And what is the mass of the hanging rope? Total mass per total length multiply by the hanging rope is L1. So this is the mass of the hanging rope. Now you can easily find the weight of the resting rope, that is mass per total length L minus L1 times G. This is the weight of the rope acting downwards. And what is the weight acting on this hanging rope? m times g. What is the mass? Here is the mass. Mass, total mass per total length multiplied by length of hanging mass multiplied by g. So we have the downward force, the weight of the object, and it experiences a tension because the hanging rope is pulling downwards. So opposite direction is the tension, and the same tension is given to the resting rope in the opposite direction, like this, to the opposite direction of the friction. And the system is not moving, so the resultant force is 0. So you can say frictional force is equal to tension, and here also the tension is equal to the weight. And we are relating both equations. We are making an equation now. Now we can, the resting rope equation, the tension is equal to friction. So what is friction formula? Mu m g. So mu is here. The mass of the resting rope is here, m by L, L minus L1 multiplied by g. Now we have equation number 1. And same we can apply for the hanging rope. Tension is equal to weight of the rope, that is mg. What is the mass of the hanging rope? M by L times L1 multiplied by g. This is equation number 2. Now we add these two equations or equal these two equations, 1 equal to 2, because the tension is equal. Both sides tensions are there. So mu m per L, L minus L1 times g is equal to m per L times L1 times g. So you can cancel these terms. Then you multiply mu L minus mu L1 is equal to L1. Okay. Now we are finding the length, hanging length of the rope. So L1 we have to find. Take this term to the other side. Mu L is equal to L1 plus mu L1. L1 is common, so 1 plus mu L. And final, this is the answer. L1 is equal to mu L over 1 plus mu. Mu L over 1 plus mu. It is the length, the hanging length of the rope, so that the rope does not slide down from the table. Mu L over 1 plus mu. Here is the answer. Thank you.